Hello everyone. Today we're going to talk about cubes and towers. Yeah, my name is Weidong Shao. Now, before we start, we would like to reiterate, the strategy to solve math problems. The most important one, of course, is to understand the problem. A lot of times, students read, a problem statement, but they may not understand, what the question is asking for. Make sure you understand the setup of the question before you provide an answer. And then you need to pick a plan or strategy for the problem and then carry out, execute the plan, and finally you have to check the answer. Of course, for this class, we're going to introduce some strategy for certain type of problems. Over the years, you're going to learn new strategy to solve different problems, and your skills getting stronger and stronger. And of course, common strategy here could, like find a pattern in the problem setting, or make a table to, organize your thought, or draw a picture, or sometimes you work backwards, for some of reasonings, and make an organized list, or use reasoning. Of course, it's important to show the steps of your work instead of only writing down the final answer. This is so that the teacher or yourself at a later time could understand your line of thoughts, um, and the strategy and method that reach the final answer. So today's topic is a cube. So what is a cube? Cube is a three-dimensional object that we deal with in our daily life. A lot of you may have played with Rubik cube, where it quite a challenging game to try to put all the size with the same color. And we know that there are six different faces here. So as this diagram shows, you know we for the cube, we call this edge, and this surface here we call a face, and then this intersection point of a different surface here would be vertex. Right. So in this case, you can see that we have six different faces, and then along these edges we have a total of 12, right? And then the vertex we have 8. The 4 on top, 4 on the bottom. Right, this is a three-dimensional illustration of that. So we mark 6 different faces with number 1 to 6. All right, so this is 1, and then 2, 3, 4, 5, and then the top is 6. Of course, when I say top, it may be at the bottom, depending on how you rotate the cube here. Of course, once we have fundamental unit cubes, we can use it to form different shapes, as we see here in this diagram. Of course, for the rightmost, we can use smaller cubes to make a bigger one. In this case, we have 3 by 3, 9 cubes on each layer, and then we have 3 layers. Total, we have 27 smaller cubes, and make a bigger one with dimension of 3 centimeters in the edge length. Now this is just another an illustration of this concept. So we call this unit cube. Okay, it has 1 centimeter in the length, and then we use 8 of them to build a bigger cube with 2 centimeter long along the edge. Right? So we have 4 each layer, and then we have 2 layers. We have total 8. Now similarly, we can use it in the same unit cubes to make even bigger ones. In this case, 3 by 3 by 3 in the depth and the height and width. All right. So the total would require 27. All right. So the problem number 1 is how many unit cubes are required to build a cube with an edge of 5 centimeter length. All right. So use the same line of logic. We know that in order to make a 5 centimeter long, we need 5 unit cube 9 together. This is 5 centimeter. And then for each layer here, we would require a 5 by 5, which is 25 cubes to make a one layer of it. Of course, we have 5 layers. It's 1, 2, 3, 4, 5, and each layer would require 25 of them. So 5 times 25. The total would be 125 cubes in order to make this 5 centimeter long edge, cubes. Now, as we see earlier, you can also build a rectangular shape. All right, so for this box, we have 2 centimeter high and 3 centimeter wide and 1 cm deep. All right, so it's like this. So how many cubes do we need? Let's count. 1, 2, 3, 4, 5, 6. So the formula we figured out is that we use the length times the width times the depth. We figured out the total unit cubes required in order to build this shape. In this case, the answer is 6. Now, we're going to look at another set of problems. And in this case, we build a bigger shape and then we paint it, paint the surface. All the faces are painted in red. But when you look at the individual unit cubes, however, not all the faces are painted in red in this diagram. Like for example, at the corner, you may have 3 side painted, but then remaining one, the inside one is not, is still white. Let's say the original color is white. And on the top, only the surface here is painted in red, and the rest of it, when you take it out, is all unpainted. Is so. Now let's look at another example. In this case, the edge is like 2 centimeter, in the length, and then we have total of 8 cubes. Now, if we paint the whole thing, the outside faces in red, and how many faces of the individual cubes are painted in red? All right. So we notice that in this case, 3 outside faces are painted in red. So we have, and each, when we look at each of the unit cubes, they all have 3 sides painted in red. So totally we have 24 faces have the paint. Of course, in some questions they ask not the faces, but how many small cubes that have let's say 3 sides painted in red. In this case, 8 of them. The 8 cubes all have 3 sides, three faces painted in red. So in this problem, we have a wooden cube that measured 3 centimeter along each edge and is painted in green. All right, the color, of course, doesn't matter. We can pick any color. Now, the painted cube isn't cut into smaller cubes. We have 27 of them, as we figured out earlier in this lecture. Now, I have 2 questions. One is, how many of these unit cubes do not have any green paint at all on any face? And how many such cubes that have only one face painted in green? All right. So similarly, when you imagine that, if this is painted in green, the corner one always have like 1, 2, 3, out facing and faces painted, and then there may be something hiding inside. Think about it. On this layer, everything is outside, but in this middle layer, the middle one is actually not touching any surface here. Okay, it's all inside. So that means it's not get painted. And how about any other ones? And this one, you know, would have all pieces, at least one or more, painted. So the answer is there's only one face that is not painted at all. Now the next question is how many cubes that have only one face painted? All right. So this diagram kind of illustrate this idea. When you look at it, when I look at any surface, right? The one on the top would have three faces painted, similar to this one, and this one, and this one. And the one here in the middle, it would have two sides painted, and here would have the bottom and this side, you know. And the only one that is have the center one has only one side, one face painted. And we know that this cube have like a six, the bigger cube has like six faces. So each, you know, middle one, the center one, has one face painted, in green. So the answer would be 6 in this case. All right. Now, another structure we call it towers. When you build towers, you kind of build from the bottom and then layer on top of it, on top of it, and then on the top. Now, usually, in order for towers to be stable, you want to make sure that the bottom layer is always wider, so that and the top, anything on the top, you would have something, to support it on the bottom, right? So, and in this case, we assume that there will always be cube under one, except for the top and bottom layers. Okay. So here's how many cubes are needed to build this tower. When you think about it, and so we have to count, by the layers. Let's see how many layers we have. We have, one on the very top, and then two, three, 4, 5, 6 layers. And then we observe a pattern here. On the very top, there's only one cube. As in the in order to support in the here, it actually extended to 4 different directions, right? So you're in this layer, there's one that is not visible because it's right underneath the top one. So plus the one that we can see outreaching, in 4 different directions. So total we would have 5. All right. Now use a similar logic. This layer would have, at least the same kind of repeating from the layer 2, but also extending one out in 4 different directions. So in other words, you observe kind of a pattern here. You have 1, and then you have 5, which is 4 additional ones. And here you would have 5 original ones that is the same as layer 2, but you have 1 on each direction. Then you have 9, right? 1, 5, 9. So in other words, each layer when you go down, you have 4 more cubes in that layer. And then we repeat this process until we reach 1, 2, 3, 4, 5, 6 layers. All right. So the top layer has 1 cube. The layer below has 1 cube beneath and 4 around it. The total is 5. The third layer has 5 cubes below and then 4 new ones, so the total is 9. So in other words, the pattern here is each row below has 4 more cubes than the row above. All right. So, and we have 9 times. 1, 5, 9, 13, 17, 21. You add this 6 number together, we get 66. So total 66 cubes that are required in order to build this structure. All right. So another question here is, you have this shape. Let's say, kind of stairs, with 3 in a row, but then you have different steps, step up, up, up. And here, the diagram shows, let's say, about 1, 2, 3, 4 layers. And the base, when you count this here, has 1, 2, 3, 4, 5, 6, 7 rows, and each row has like a 3 cubes. All right. So what if the stairs are taller, such that the base, the bottom layer has 21 in length, 21 rows. All right. So how many cubes in total in that structure? Remember, the structure is not drawn here. Okay. But the shape is like just like for similar to this, where on each bottom layer is you have like a one step wider on both directions. So again, in solving this kind of problem, we need to observe a pattern. Like what is the kind of pattern from the top layer to the layer down and the layer beneath. So we need to work it out one by one. All right. So here we know that at the very bottom we're gonna have 21 cubes, 21, like 1, 2, 3, 4, 5, 6, 7, not 7, but 9 and 8, 9 until 21. It's very long, and then by 3 in width. All right. So just like take the same strategy as we did earlier. So we need a sequence number here. All right. So what we need to do is to figure out the pattern and then come up with the numbers and then add the number as a total. All right. So in this strategy, what we can do is we know the bottom has like 21 times 3, and each time we go move up, we notice that the length is actually reduced by 2 because there's one less step here, there's one less step there. So here in this case 7 and then 5, 3, 1. So if you have 21, we would go through 19, 17, 15, each time decreasing by 1, right? And the very top, however, we didn't have 1. So, and then because we have this stair is wide, like 3 cubes wide, so each time we have 21 times 3, and each layer is like times 3 total cubes on each layer. And the subtotal of each layer, we calculate like that. And then we're going to add them up. Okay, there's a trick here, to add this type of number in sequence, and if they have equal difference, in this, in each between each two numbers, okay, either increasing by the same amount or decreasing by the same amount. In this case, like if you count this way, it's like 3, 9, and 15 and 21. Each time is increased by 6. Or if you count that way, it's decreased by 6. All right. So there's a trick, which is you're going to use the um, starting number, which is 3, or 63, depending on which way you count it from. And, and the starting and the end number added up, and then times the number of items, which is in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so you have this, you add it up times 11 and then divide by 2. All right, so that would give you a number 363. Of course, you can also use calculator just to calculate individual sums. All right. So the final question today, we're gonna look at stairs again. These stairs just similar to the one shown here, but again, it's not identical as this one. We say that this has like 10 steps high, and the base is like 3 steps in wide. Each building block is 1 cube. Okay, so how many cube does this builder list? All right. So when you think about it, it's first similar to the problem that we look at here. Here we know the bottom kind of size, and here we know what is the total length. For the total length, we know that at the very top you have 1, right, and then 2, and then 3. Each time you increase by 1. In the earlier diagram, each time you increase by 2, but here we only increase by 1, and also we know that the total height is 10 steps high. All right, so we build a table again in a similar logic, and here the table says at the very bottom you would have 10 you know steps, and then times 3, and each time you decrease by 1, and you times 3. Now 10, 9, 8. Here is you have the numbers, you add it up, is 165. All right, So we solve the total number of cubes required in order to build stairs. That is 10 steps high and then 3 cubes in width. All right. So I think that's it for today's lecture. Today, what we have learned is about a cube, which is a 3D object has six faces, vertices, and um, different edges. All right, and then we build towers using that, and then sometimes we put a paint, and then we look at what faces of the original unit cells get painted. All right. So you're going to have a variation of this type of problem, and in our homework. So I'm going to give out homework on Thursday. You can check with your parents, to download and try to solve the homework. All right, thank you.